Now, when building web applications and their user interfaces, outputting dynamic data is just one thing you often need to do. You also often need to listen to user input so that you can then, for example, also update the UI upon certain kinds of input. And that's therefore what we'll do next. Listen to user input and then in a second step also change the UI after some user input. And conveniently we have this button here. So let's say for a start, we'd like to add an event listener to that button to listen for click events so that we then, for the moment, simply output something in the console. And in Angular, where you write declarative code, you add event listeners to elements by going to those elements in your templates. So by going to this button, for example, and by then specifying the name of the event you want to listen to. So for example, click. You then wrap this event name with parentheses, regular parentheses, opening and closing. So event name between parentheses. That's Angular's syntax for adding an event listener to an element, to this button here, in this case. Now, as mentioned, you could add a broad variety of event listeners. And if you add an empty pair of parentheses and you place your cursor between them and you press Control Space, most IDEs should give you a list of event listeners you could add. So here you see the click event, but also a bunch of other events you could possibly also want to listen to. In my case here, it's the click event though. Well, and then you should add an equal sign, and then between those quotes, you add the code that should be executed when that event occurs. Though typically you don't add it here in the template, but instead inside of some method that you define on your component class. And that's what I'll do here. In that user component class, I'll add a new method and I'll name it onSelectUser. Though the name is up to you, it's just one common pattern that you'll see quite a bit, that those functions, those methods that are meant to be executed upon some event start with on as a prefix to make it clear that they're meant to be executed upon some event. But it's not a hard rule you have to follow, and you'll see different conventions in different Angular projects. Then you add parentheses and curly braces, and with that you got a regular method as you could add it to any class when using TypeScript or JavaScript. And here for the moment I'll then simply console log clicked, just so that we can see that it worked. Now to connect this to the click event, you should use that name of that method, and then use that as a value for this click event listener and add parentheses after it, as if you would be calling it. It will, however, be called for you when that click occurs, not when this line of code is parsed, but instead only once a click on that button element occurred. Well, and with that, if you now save that, and you go back and you open your developer tools, and there your JavaScript console so that you can see log messages. If you click that element, you should see clicked here. And you will see a new output, as you can tell by this number here, which is changing every time I'm clicking this button. And that's how you can listen to events in Angular and how you can define which code should execute when they occur. Now that we know how we can react to events and that we know how we can output dynamic content, we can bring these two things together, as you often will do when building Angular applications, so that we can update the UI and what's visible on the screen whenever this user here is clicked. So that instead of just outputting something to the console, we update the UI. For example, we could change the user that's displayed here every time it's clicked. So that instead of changing it only when the page reloads, we could do that when the user is clicked. And for this, we now need to manage some data in our component class, which, when changed, has an impact on the UI. And this kind of data is often also called state. because it is data that will have an impact on the state of our user interface. And setting up and using such state is actually pretty straightforward when working with Angular. Indeed, you actually don't need to set up anything special at all, unlike in some other libraries or frameworks you could be using instead of Angular. Instead, here in our user component, we just need to change the value of selected user whenever this method down here gets executed. So in this method, instead of console logging, we want to set this selected user to a different selected user. And for that, of course, we can copy this code and paste it in there. But we now also need to make sure that random index changes every time this method executes. Because at the moment, it's only calculated once initially when this file gets parsed and never changed thereafter. So in order to get a new random number, we can of course simply copy this entire line here and paste it into onSelectUser, so that we generate a new locally scoped random index constant that's only available inside of onSelectUser and that overrides this global random index constant inside of this method here at least. And we then use this random index, which is recalculated every time this method runs, to extract and store a new user from dummy users. So the selected user property gets changed every time this method executes now. And this method executes whenever this button is clicked. Therefore, with this simple change made, if we now reload and we click, you see that the users will change. And that's how easy it is to manage data in Angular, which, when changed, has an impact on the UI. You simply change the properties you're outputting in your template. It's as simple as that. In the previous lecture, you learned about state. So about data stored in properties here, which when changed has an impact on the UI. And that data change has an impact on the UI due to how Angular's change detection mechanism works. Because Angular automatically detects and finds out when data changes, and it then simply takes a look at the template of the component and verifies whether that template, now that the data changed, maybe produces a different DOM snapshot. And if that's the case, it goes ahead and updates the UI so that changes are reflected there. Angular does all of that automatically. And it does all of that automatically with help of a part of the Angular framework that's called Zone.js. Now, Angular is using this Zone.js thing under the hood. You don't need to use it yourself as an Angular developer, but it is interesting to understand how it works. Because what this Zone.js thing, this part of the Angular framework, does is that it automatically listens to all possible user events that could occur on a website, for example, as well as some other possible events that could occur, like a timer expiring or anything like that. And when such an event occurs, it checks the Angular application for possible changes. That's how change detection works in Angular in a nutshell. And that's why we got this almost magic behavior where we can simply change some data, some value stored in a property here, and the UI updates automatically without any extra work being required from our side.